Hey everyone, welcome back for another deep dive. You know we're all about keeping you updated on those crucial current affairs, especially for all you UPSC aspirants out there.
Absolutely. And today we've got something really exciting to unpack. We're going to delve into India's Aditya-L1 mission.
Oh yeah, this one's big. It's India's first dedicated solar observatory, you know, out there in space, keeping an eye on the sun. And guess what?
It recently made a pretty groundbreaking observation, snagged a glimpse of a solar flare. But not just any glimpse, we're talking about the first ever image of a solar flare kernel.
Okay, hold on, Colonel. Break that down for us.
Think of it this way. You know how the sun has different layers?
Yeah, like an onion.
Exactly. So this kernel, it's located in the photosphere, the visible surface, and the chromosphere, the layer just above it.
All right, I'm following. But what's so special about seeing this kernel?
Well, Aditya-L1's special eye in the sky, the Solar Ultraviolet Imaging Telescope, or SOIT for short, captured this kernel in near-ultraviolet light.
UV light, huh?
Yeah.
Important for sunburns, right?
More than that. Specifically, it saw it in the 200 to 400 nanometer wavelength range. And this range, it's vital for life on Earth.
Go on, I'm intrigued.
It directly impacts our ozone layer and oxygen levels. The ozone layer, that's our shield against harmful UV radiation.
Oh, right, that's essential. Can't imagine life without it.
Yeah.
And oxygen, well, that's kind of a non-negotiable for, well, breathing.
Exactly. But this observation, it's not just about pretty pictures, it's shedding light, pun intended, on how energy from a solar flare spreads through the sun's atmosphere.
Okay, so it's like a deep dive into a flare's journey, right?
Exactly. Scientists have been theorizing for ages about the link between energy and temperature during these solar events. And now, thanks to SESI, we have evidence
Evidence of what?
that flare energy travels through those different layers of the sun's atmosphere. And it showed that the plasma temperature, that's the superheated gas the sun's made of, increased in the corona.
Wait, the corona. Remind me, what's that again?
It's the outermost layer of the sun. Think of it like the sun's atmosphere. And it gets incredibly hot. Millions of degrees Kelvin. It's made of plasma, throwing out high-energy radiation.
Wow, millions of degrees. That's mind-boggling. But why should we care about this corona, especially our UPSC folks?
Well, understanding the corona is key to understanding solar processes and predicting space weather.
Space weather, that sounds intense.
It is. And it can have a real impact here on Earth, especially on things like satellites and communication systems. And trust me, questions on space weather are frequent flyers in the UPSC exam. Oh, and did I mention the corona is the source of the solar wind?
Right, that stream of charged particles always flowing from the sun. So, back to those solar flares, the ones that originate from the super hot corona. What causes them? And why should we care about them down here on Earth?
Picture this. The sun's magnetic field, it's constantly in motion, kind of like a tangled mess of rubber bands.
I'm picturing it. Go on.
When these magnetic field lines snap and reconnect, boom, that's a solar flare.
It's a sudden release of energy?
Exactly. And they release a whole lot of radiation. X-rays, UV light, the works. And this radiation, it can mess with our tech here on Earth. Satellite communications, GPS, even power grids.
Whoa, so these flares can really disrupt our lives.
You bet. And they're categorized based on intensity, A, B, C, M, and X, with X class being the heavy hitters. Important to remember for your UPSC prep.
So DTL1 and its ECN instrument are giving us a front row seat to this whole solar flare show, right? But what makes ISIA so special? How does it get those awesome images?
Well, SEO's secret weapon is its ability to see in a specific wavelength range.
Yep.
2000, 4000, no one's ever explored this region for solar observations before. It allows SEO to study those high-energy flares and radiation from hard X-rays to infrared.
Like having a superpower vision for the sun.
And not just that, SEO is also supporting in-situ measurements at the L1 point.
The L1 point.
Yeah, it's this special spot between the sun and Earth where gravity from both kind of balances out. Being at L1 lets SEI directly sample the solar wind and magnetic field.
Real-time data. That's amazing. So it's like having a weather station in space, keeping tabs on the sun.
You got it. And all of this is just from one of 7 instruments onboarded to TL1. Pretty impressive, right?
India's space program is really making waves. Our UPSC aspirants should definitely take note of this for their mains answers. It shows India's growing prowess in space technology.
Absolutely. Aditya-L1 is a game changer. The data it's collecting will help us understand the sun and its impact on our planet like never before.
To wrap it up, Aditya-L1 is a huge leap forward. Not just for India, but for the whole scientific community. It's giving us this incredible insight into the sun and helping us prepare for any space weather surprises headed our way.
Knowledge is power.
And speaking of power, here's a question for all you UPSC aspirants to think about. What can we do to protect our tech-dependent world from the effects of those powerful solar flares? Food for thought.
Definitely something to consider.
If you want to delve deeper into this, check out the Hindu and the Press Information Bureau. They've got some great articles on Aditya-L1 and its findings. And as always, don't forget to like, subscribe, and leave us your comments. We love hearing from you. Until next time, keep exploring.